Hello, everyone. So this is the last hands-on that we are going to do on SQL. So this is for week 7. And as always, I'm going to upload the script on Moodle, but we're going to do it together now, just so that we can discuss a few things which are worth being noted over this lesson. So the three topics that we need to cover for this one are the joins, so inner join, outer join, full and cross joins. Then we're going to discuss the views, how to create and use a view, and then the temporary tables. So I'm starting with a database which already has the tables inside. You already built them before, and if you have a look at them, you can see that there is data in there. So these are the books, the readers, and I also have genders and rates. Now we are going to focus mostly on on readers and rates. And we're starting from the joins. So the very first join that you have seen in the lesson is the cross join, which basically means taking all the possible pairs between two tables. So in this case here, we are using the reader table and the rate table. So if once again, look at the reader table, you will see it has right now 3 elements. So it's Luca, Anna, and John. John is a new one. You probably don't have it. So in that case, I will show you later on how to add it. And rates has 6 elements, 3 ratings from Luca and 3 ratings from Anna. Now, if you do a cross join, it basically means take each and every possible combination of readers and rates. So because we have 3 readers and 6 ratings, we are expecting 18 lines as a result. And indeed, if you look at this, there are 18. So the very first important thing to notice is that they don't necessarily make sense. So you will find, for example, a line with Luca as reader linked to the rating of Anna. Let's have a case like that. So if you look at this one, Luca with Anna, this one, this is line 6. If you look at line 6, the reader is Luca, but here is linked to the ratings, ISBN, email, and rate of Anna. This is because we are not imposing any constraint on how we are joining these two tables together. We just tell the system we want all the possible combination. So you can do it by using a comma, or you can explicitly say cross join. The result is exactly the same. So if I do this, it goes back to our 18 lines and the same outcome comes out. Remember also we can use aliases. For example, we can use an RD for reader, an RT for rates, and then we can use RD.star, RT@star if we want to. If I do this, again, it's the same results, but this time I'm using aliases for the tables. Now, of course, building all the possible combinations doesn't really make sense. Ideally, I want to have the reader Luca linked to the ratings that he gave, Anna with the ratings that she gave, and John in case there are any rates. So to do that, I'm using an inner join. Inner join means take a row on the left side of the join, which is this table, join it to a row on the right side of the join. See, the join is in the middle, only if there is a connection between the two. So if I run this one, now I'm taking the 3 ratings of Luca linked to the reader Luca, and the 3 ratings of Anna linked to the reader Anna. So this makes much more sense. This is actually where you can insert a new reader in case you don't have it yet. And the reason why I'm doing this is to show you that although John is present in the readers, when you run an inner join, John doesn't show up because it doesn't have any rating associated with him. If instead I want to see all the readers, even those which are not linked to any rates, then I need to use a left outer join. A left outer join if I put the reader on the left side of the join. You see, this is the join, and there is a left side and a right side. And basically, we are navigating using the foreign key. If you do something like this, what happens is that now, again, you see Luca linked to the ratings of Luca, Anna linked to the ratings of Anna, but this time you also see John. However, John doesn't have any rating, So the corresponding columns are left to null, 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 null. But at least now you see it. So sometimes this is useful. Suppose I ask you an exercise in which I want to see all the readers and then I want to see the country name where they were born. But if a reader doesn't have a country code, I still want to see it in the output. Then I need to use a left join. Of course, I can also use a right join. The right join means doing the same thing as the left join, but with the table on the right. So to give you this example here, what I've done is to use the right join, and then I swapped rates and reader, and I'm basically going to get the same result. Only this time I see first the columns of the rating table, and then the columns of the reading table, because the reading table is on the right side of the join. But again, John comes out with null, null, null on the rating. Another type of join that we have seen is the full outer join. Now, the full outer join means take whatever is on the left table, even if it's not linked, and take whatever is on the right side of the join, even if it doesn't have a match. Notice that this is different from a cross join. A cross join means all the possible pairs. In this case, instead, we say all the readers, even John, all the ratings, suppose that we had a rating not linked to any reader. And in those cases in which there is no match, we want to see null, null, null in the other columns. Now, you need to know that in some DBMS, like Maria Database and SQLite, the full outer join is not supported. But still, you can get the same result. So if I try to run this, say if I try to run it, I get an error because it doesn't know what this is. However, you can implement the full outer join by using the left join union to the right join. Of course, in this case, I'm not swapping the table, so otherwise it would be the same command. So I'm saying take the reader left join rates and the reader right join rates and union them together. So doing this is exactly the same as doing a full outer join. Now, this is not the case in which you can see the right part being null because we don't have any ratings, which is not linked to any reader, but there may be cases in which that happens. And when that is the case, then the full outer join does exactly what I just told you. Okay, when you have a join operator, of course, you get the result set from this part of the select, which means that after that, you can just do whatever else we already saw. So we can do a filtering, for example. So take all the inner join and then show me only those with a rate higher than 3. And this is perfectly fine. So we have one for Luke and one for Anna with rate 5. You can also, of course, use aggregations. So if you want to count how many combination of readers and ratings you have, and you get number 6 here. You can do the group by. For example, we can group by rate and ask for a rate and count. So this means for each possible rate, I want to know how many ratings I have. So I have 2 ratings with rate 1, 1 rate with rates 2, 1 rating with rate 3, and 2 ratings with rate 5. Okay, so this covers more or less what you've seen in the slides for joins. Of course, you need to spend some time understanding them. They can be very, very powerful. When you combine all what you have seen so far, so aggregation, joins, group bys, then you can nested queries. You can start building very powerful query commands. The next 2 topics are the views and the temporary table. So a view, if you remember, is a non-materialized table. So if I decide to use this select here, let me just run the select for a second. So the select gives me the rates higher than 3 in inner join. If I define a view with that select, now I think I already did that, so probably, no, it's not there, so I can actually do it. So let me just create a view. Everything is fine, and if I refresh the view now, I should be able to see it there. Here is my view. And now I can use it as if it was a table. But again, it is not a real table. It's not materialized. Every time I'm using it, the DBMS actually runs this command in order to generate it on the fly. So I can do something like this. And what is actually happening is that the system runs select star from, parentheses, select, and all the other things that you have here. Of course, you can remove a view just like you can remove a table. So you can run a drop view. And in that case, the view is gone. The last 2 things we want to see are the temporary table. Now, The temporary table, as a temporary table, there is not much to say. It's just as any other table, but it lasts only for the duration of the session. So if I create a table, which is a temporary table like this one, 10 customers, if I refresh my tables now, I will see it there. But the moment I will close the client and stop the sessions and open the client again, this table will be gone. It will not be persisted. It's only in memory, and you can use it for the time that is needed. Then we have the last topic, which is the common table expressions, which basically means we are building a temporary table during the running of a command. And during that time, this table exists only while I'm running this command. So for example, here I'm saying, I want to run a select, but I want to do it on a specific table, which I'm building on the fly. And in this case, it's like a select email and a count of number of rates, again, from the same inner join, group by. I mean, this is not really relevant. What is important is that this one is building something. It's building this kind of table. We are giving this a name, myCTE. And while we are running this command, we can use myCTE as if it was a real table. So select my email from myCTA, where whatever other condition I want to put. So this can be run together. It works, but this is not really a table that is created anywhere. It only exists for the duration of this command. And it allows you to build complex selects in a more linear fashion. So instead of having to put a lot of nested select queries one inside the other, we can just build a temporary table useful only for that select. And once the select is finished, then the table is gone. Okay, guys, this is all I wanted to show you for week 7. Spend some time exercising on these things because they're very, very important. And this is also the last hands-on that we're going to have throughout the course, because the next topics are the NoSQL and the business intelligence part. And for those, we have a lesson dedicated to that, a full week. So you actually have a set of slides, a PowerPoint deck of slides with an exercise on it. So there will be no need to create an additional one. Okay, thank you very much and have fun trying this code out. Bye-bye.